Hi. So this is also part of Monday, Tuesday work. Um, have you ever swung on a playground? Can you describe or graph your motion while swinging? That's an interesting question. Do you ever feel like the swing stops at a certain point or the swing goes faster at a certain point? What do you think causes these changes in speed? Do you think your energy is also changing as you swing? Energy can change within a system, can take many forms. What do these forms have in common? They all have the ability to cause changes to a system or a set of connected things that work together. So, from the previous video and notes, a system is a set of connected things that work together, usually defined to help us solve a problem. As you swing on the playground, you and the swing form a system. The increase or decrease of energy in a system has a direct effect upon the system's physical variables. These variables include temperature, speed, position, pressure, and motion. If someone turns on a stove burner sorry, under a pot of water, energy from the burner will cause the pot to heat up. The heat will then cause the water to come to a boil. This shows a relationship between energy and the system of a water-filled pot. So because those things can exchange energy with each other, if you happen to touch the pot and burn yourself, then you would actually become part of that system because the thermal energy would transfer into your hand. Physical variable is something measurable that can change. I don't know. First time doing it, like recording with Cami. Energy can be classified as potential or kinetic. There's two main forms of energy in a system, potential and kinetic. We talked about kinetic last week. We're talking more about potential this week. Potential energy is stored energy, and kinetic energy is energy in the form of motion. Total amount of potential energy and kinetic energy in a system is known as mechanical energy. So when you think about the swing, this diagram shows how the swing moves back and forth as a person rides it. When the person has swung all the way back to position A, which is here, the swing pauses for a moment. At this moment, the swing has only potential energy. So that's a really quick moment if you've done much swinging. Sorry, I lost my place. The swing then falls forward, gradually gaining speed. As it falls, its potential energy changes to kinetic. So once it starts moving again, you go to kinetic energy. At position B, the swing only has kinetic energy because it's in motion all the way. As the swing continues forward, gradually slows down, its kinetic energy changes back to potential energy until it reaches the farthest point in its arc. So the arc is just the curve. Position C, so that would be here. That other pause that you have when you're swinging. Oh wait, it's backwards. Oh, there it is. When you stop, potential, kinetic, potential. Um, so you can feel that too, that little bump at the top when you're swinging. Um, Here the swing pauses again. That's at position C. At this moment, the swing only has potential energy. Then it falls back through its curve again. Its potential changes to kinetic, and the cycle goes on and on. So energy can change back and forth over and over again. At every point in this cycle, the system of swing and person has the same amount of mechanical energy. In other words, when the system has less potential energy, it has more kinetic energy. And when the system has more kinetic energy, it has less potential. At each moment, the system's kinetic energy and potential energy would add up to the same value. So you would have potential and kinetic as you're falling, then kinetic, and then back to potential. And if you add it up, if you were to do the math for those, you should get the same values. Now, just a side note here, asterisk. I'm sorry, my voice sounds crappy and my face looks all crappier than normal. I'm all stopped up, so apologies. If you were to do the math, so kinetic is 1/2 mass times the square of the speed or velocity, and potential is mass times gravity times your height. So it's mgh. Or if you have your weight already, it's just weight times your height, because mass times gravity is weight. So if you were to do the numbers, you should get the same total. But a lot of times on like in real life, it's hard to actually match those numbers up. So just know that. And it's because of things like friction, air resistance, other things that we don't really think about that cause our systems to lose energy. But your problems on paper, they should add up to the same value. Look out. Those always make me laugh. You may think that as the swing gains speed, its potential energy is destroyed and the kinetic energy is created. In fact, energy can only change forms. It cannot be created or destroyed. This is called the law of conservation of energy. Why can't you swing forever? Where does the energy go? As you swing, your body collides with particles of air. These particles are tiny, but there are lots of them. Each time you collide with air particles, a little of your kinetic energy is transferred to the particles. This force, called air resistance, gradually slows you down. Another force that slows you down is called friction. As the swing moves, its parts rub against each other. As this happens, some of the swing's energy changes to heat and leaves the system. If there were no friction or air resistance, you could swing forever. Potential and kinetic energy are similar but not the same. Scientists measure both potential energy and kinetic energy in joules, capital J. Um, Make sure you remember this, because in your word problems, it's not always going to say the energy of whatever was, it's not going to tell you. It'll just say 40 joules were, part of the system, and you'll have to know that that's energy. Units are important. A joule describes the amount of energy needed to do a certain amount of work or cause a certain amount of change. So more joules of energy can perform more work or cause more change. Scientists can use the same unit to measure both types of energy because kinetic energy and potential energy are related. Remember, a system's mechanical energy equals its kinetic plus potential. I think I said that backwards, but you guys know what I mean, right? So your total energy of your system is potential plus kinetic. There are also differences between potential energy and kinetic energy. Potential is stored energy. In other words, it has the potential to become kinetic energy or to do work. The chemicals that make up food, batteries, and fuel all contain potential energy. When you eat food, your body converts the food's potential energy into kinetic energy you can use to move and function. When fuel is burned in a car engine, the fuel's potential energy is converted to kinetic energy that powers the car. Essentially, kinetic energy is energy of motion. Wow, that was so not good. As you move faster, your kinetic energy increases. As you add more mass, the kinetic energy increases because of the formula. That being said, how speed and mass affect kinetic energy is not the same. This is the labs that we did last week. An object's kinetic energy depends on mass. Kinetic energy is directly proportional to mass. Anytime you see directly proportional, what that means to you as a young scientist or mathematician is that the graph would look like this. So this is directly proportional. You'll see a line, a straight line, and the slope of it would be whatever your y over x is. Kinetic energy is directly proportional to the square of the object's speed. Also, that comes from, sorry, my stylus is crapping out, the formula, because the formula says kinetic energy equals 1/2 times the mass times the speed squared. I have no idea why it went wrong in the center. Pretend there's an S. That's the reason why it's directly proportional to the square of the object's speed. And if you remember, that was a curve. That graph wasn't a curve, like a little arc upward. That's what the directly proportional to the square looks like. But directly proportional will always be a line. That's probably a long enough video for this one. I'll make another one to work out these problems at the bottom if you need help. I hope you're having a great day.